Student, today we will learn the chapter Limit and Derivatives. In the previous video, I have just described about you the word limit. Okay, and after introducing the calculus, I have described you the limit. Now, I am telling you in this topic some algebra of limit and some special formulae to finding the limits. Okay, so student, what is the algebra of limit? Algebra, you know that addition, subtraction, multiplications and divisions. So algebra of limit means addition, multiplication and subtraction and division. So let you have f and g be two functions such that both limit x tends towards a fx and limit x tends towards a gx exist. Now we have taken here the same limit, x tends towards a and x tends towards a. Then we can say, as I have explained, that what is the meaning of algebra: addition, subtraction, multiplications and divisions. So limit of sum of two functions is sum of the limit of the functions. It means we can say limit of two functions if we take in this way fx plus gx. So we can say, we can take this way fx plus limit x tends towards a gx. It is the addition. Similarly, for difference, we can say fx minus gx. Then we can write limit x tends towards a fx minus limit x tends towards a gx. Okay. Similarly, for product, as two functions in product, then limit x tends towards a fx into gx. So we can say limit x tends towards a fx into limit gx, x tends towards a. Similarly, for division, for quotient of two functions, let limit fx x tends towards a upon gx. So we can write limit x tends towards a fx and limit x tends towards a gx. But here denominator should not equal to 0. Okay, if denominator is non-zero function, here denominator is non-zero function. Okay, so this should be understand. If it is equal not 0, then you can take this value. And also if we want to take the limit of any constant function, limit x tends towards a of constant function is always answer itself constant. Now if a constant function is multiplied with another limit, so we can say k is here gx, x tends towards a. After understanding this, we can conclude some true limit. Now for polynomials and rational numbers, first for polynomials, for examples, limit of x square, x tends towards a, we can check directly putting here, we find answer a square. So here is the answer directly since it is a true limit. I have already explained in the previous lectures, it is the true limit. So for all polynomials, and what is the polynomials you can understand better. If you don't understand the polynomials, we should be read the chapters polynomial first. So we can explain for x to the power n, limit x tends towards a, we can directly put here x equal to a since it is true limit. Okay. Now second point is for rational expressions, for rational functions, for rational functions, and you know the rational functions in the question form, isn't it? Here is an examples for that. For rational functions, if fx upon gx, x tends towards 0, x tends towards a, if here is true limit, then we can put a directly. Examples, fx upon gx, x tends towards a, let here is the question x square plus 2 upon x plus 1, x tends towards 2, we can take directly here, putting this value here, x square plus 2, x tends towards 2 as quotient law, x plus 1, x tends towards 2. We can see here is a we can put here is a true value. So we can put here 2 square plus 2 upon 2 plus 1. So we can get here 6 upon 3 equal to 2. So it is a true limit. Okay. But now student, here is a main examples. Main examples is here that if you're finding this way the questions, as I have already explained in the first video, let fx equal to x square minus 4 upon x minus 2, and you want to find f2, so you can check here, that is 0 upon 0, it is indeterminate. It is undefined or indeterminate form, you cannot find the value of 0 upon 0. It is here is a irrational form, but you cannot find directly 2. Now if you want to find the limit here, so x tends towards 2, if you want to find this limit, for this function. Now if we use the factors formula, x plus 2, x minus 2 upon x minus 2, x tends to 2 cancel out here. Now putting this value, you can find the value, it is the limit. So student, for rational numbers we use so many formulas and factors. So we can say indeterminate forms are in the form of 0 upon 0, 0 into infinite, and infinite upon infinite, 0 to the power infinite, or infinite to the power 0, and so on. These are undetermined form, and how we will get this type of the questions for limit. So first method is, that is the to define it, calculation method, as already explained in the previous video, so I will not do this method. Second is factor method. In this factor method we always use a common factor to cancel out from numerators upon denominator, as we have done in the previous examples. And for cancel out the factors we use so many formulas. Okay, so now come to the some questions and some formulas. So we will explain a formula. Let for any positive integers n, we can use the formula this way: x to the power n minus a to the power n upon x minus a, x tends towards a. You can use directly this formula, and a to the power n minus 1. And now we are going to be provide this formula, prove this formula. Let it is proof. LHS x to the power n minus a to the power n upon x minus a, x tends towards a. Now student, you can find a factors of this using factor theorem. Dividing by x minus a, you can find the formula this way: x minus a, x to the power n minus 1, a to the power 0, plus x to the power n minus 2, a to the power 1, plus x to the power n minus 3, a square plus dash dash dash, and plus x to the power n minus n, a to the power n minus 1. Now upon x minus a, x tends towards a, you can see this is the formula factors we can cancel out. So now putting this value a, we can find a to the power n minus 1 into 1 plus a to the power n minus 2 into a to the power 1 plus a to the power n minus 3 a to the power 2, and so on, plus a to the power 0 into a to the power n minus 1. Now these are a to the power n minus 1, this is also a to the power n minus 1, this is also a to the power n minus 1, 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 a to the power n minus 1. These are n times factors. Okay, it is 0, it is n minus 1, so we can say n minus 1 factors. And factors, so we can write here adding n times a to the power n minus 1 equal to RHS. Now using this formula we can do some questions on this rationalized type of the factors easily way, directly using this formula. Okay students, now we can make another formula of this way: x to the power a m upon x to the power n minus a to the power n, x tends towards a. Now we can say if we divide this by x minus a, and again we can divide this by x minus a. So we can write this way. So now using the limit theorem, we can say x to the power minus a upon x minus a, x tends towards a upon x to the power n minus a to the power n. And using the previous formula, we can write it m x to the power m minus 1 and divide n x to the power n minus 1. Again we can write x to the power m minus n. So using this formula, we can directly use some questions on this formula. Okay, so before going some more formula, if we'll do some questions of this type of the polynomials, you can then better understand of these questions. Now the question is, evaluate x to the power 15 minus 1 upon x to the power 10 minus 1, x tends towards 1. So as I have already explained this formula, it is m, it is n, so we can write 15 upon 10, it is 1 to the power 15 and is 1 to the power 15, so we can write here 15 minus 10, here is 3 by 2, 1 to the power 5, it is equal to 3 by 2. Okay, now another questions we can say under root 1 plus x minus 1 upon x, x tends towards 0. Okay, so using formula x to the power m, so here is 1 plus x, let we take here, let 1 plus x equal to y. So we can say if x tends towards 0 means 1 plus 0, so we can say y tends towards 1. So x equal to, we can write y minus 1. Hence we can say this question is equal to y to the power half minus 1 to the power half upon y minus 1 and y tends towards 1. Now it is a formula, so we can write m and 1 to the power n minus 1, so 1 by 2, and this is also 1 upon to the power 1 by 2 equal to 1 by 2 into 1 equal to 1 by 2. So it is your answer. So this way we can use the polynomial types of the questions. Now if we go some more formula related to this limit, so we can say we will find some limit of trigonometrical functions, and also we can find some other type of the functions. So if we use a theorem that let f and g be two real valued functions with the same domain such that fx is less than equal than gx for all x in the domain of definition for sum a if both limit x tends towards fx. X tends towards a fx and limit x tends towards a gx exist, then limit x tends towards a fx will be less than equal than limit x tends towards a gx. This can be illustrated in the graph this way. Let a function has this way and another function has this way. This is a common point. It is y equal to gx and it is y equal to fx. So we can say this, the fx is less than for all values of x less than gx. Now using this property we can say a very important theorem that is known as the Sandwich Theorem. It is a very important theorem. For this we can say first illustrate the graph. Let here is a function of y equal to hx and here is another function which is less than y equal to gx and here is also another function y equal to fx. At a. So according to this Sandwich Theorem, if f and g, f, g and h are real functions such that let fx less than equal than gx less than equal than hx for all x in the common domain of definition. For some real number a if limit x tends towards a fx equal to let L equal to limit x tends towards a hx, then we can say then limit x tends towards a gx is also equal to L, and you can say it is between this sandwich means in the between two values. If gx is less than hx and greater than fx, then limit of this is also equal to L. Okay, understand? This is the sandwich. Sandwich means according to name, between two things. Okay, so we can say a questions accord for this. Using this we can say questions. Now cos x less than sin x upon x less than 1 for 0 less than mod x less than pi by 2. Now proof of this. Now we will take the limit of this and this, then we can find the limit of this using the Sandwich Theorem. So first we will prove this inequalities, then we will take the limit of sin x upon x. This will be very helpful to find the limit of trigonometrical functions. This is so. Now you can see here is a circle. Okay, let this one is the center. Now draw this radius and produce it, and draw perpendicular from this, and take a point on here, draw perpendicular from this point. Let the given the name here OD. Let here is A, C and B. Now this one is 90 degree, this one is 90 degree. Now using this figure we can say, since sin minus x, we know that is minus sin x, and cos minus x, we know that it is equal to cos x. So hence we can prove inequalities for 0 less than x less than pi by 2 only. Now in figure we can see that area of triangle OAC, area of triangle OAC, let's join here, half into base into height, base is OA, height is CD, will be in figure less than area of sector OAC. This is a sector OAC, this one is a sector. Okay, and you can see in this figure also less than area of triangle OAB. In this figure you can see OAB triangle area and OAC sector and triangle OAC. This is the common point. Okay, so you can see this value in this figure. According to figure we have write this one. Now we can say area of triangle OAC half into base, let the base is OA and height is CD, half into base into height less than, and area of this, let this angle is x. So we can write theta upon 2 pi into area of triangle pi radius OA square. What is the area of the sector? Theta upon 360 into pi r square, and that's less than half OA base and height is AB. So if you know the formula of sector, okay, so you can write it, and now cancel the common part, but we get it, half OA cancel, half OA cancel, half OA cancel, and we write here CD less than x, pi is also cancel OA, half OA is cancel, half OA cancel, pi is cancel, x OA less than AB. Okay, cancel out the same values. Then now in triangle here sin x equal to perpendicular upon base, so we can find CD upon OC, and since OC is radius, here also we can write OA. Okay, so we can write here we can change their value of AB using the tan x theta, tan x equal to perpendicular upon radius. So putting this value, we can find here, we can write here sin x equal to and tan x equal to in triangle OAB in triangle ODC, that is perpendicular upon hypotenuse OC and here perpendicular upon base OA. Since OC equal to OA equal to radius, hence sin x equal to CD upon OA. Hence we can write here in the previous line CD less than x, OA less than AB. Putting the value from CD, we can write OA sin x less than x, OA less than AB, we can put from here OA tan x, and again cancel out the OA, we can find sin x less than x less than tan x. Again we can write sin x less than x less than sin x upon cos x. So we can cancel out the sin x, so we can write here 1 less than x upon sin x less than 1 upon cos x. Hence now reciprocal taking of this sign will be changed, so we can write cos x less than sin x upon x less than 1. So this inequality is proved. Now using this we can a important formula. Now by Sandwich Theorem, so by Sandwich Theorem, now taking the limit of cos x, x tends towards 0, we can find true limit that is equal to 1. And taking the limit of x tends towards 0 of 1, that is 1, it is true limit. So using the Sandwich Theorem, we can say sin x upon x, the limit x tends towards 0 is also equal to 1 by Sandwich Theorem. Since we can say the limit of this equal to limit of this, so we can say limit of this is equal to 1. Okay student, so it is a very important formula, that sin x upon x, limit of this is equal to 1. We will use this in some questions. Okay, here the meaning of sin x upon x, that is variable, x variable tends towards 0. Okay student, now we can say one more formula, that is the 1 minus cos x upon x, x tends towards 0 equal to 0. This formula also we can use. Now proof of this, LHS 1 minus cos x upon x, x tends towards 0. Now we know the formula of cos theta, we can cancel out this 1 here, we can write here 2 sine square x by 2 upon x, x tends towards 0. Okay, now cos 2 theta equal to 1 minus 2 sine square theta, cos 2 theta equal to 2 cos square theta minus 1. These are the basic formula, you have to learn it. 1 minus cos 2 theta equal to 2 sine square theta, and 1 plus cos 2 theta equal to 2 cos square theta. So here 1 minus cos x. Okay, so we can write here 2 sine square theta, 2 theta, theta, here is x, there is x by 2. Okay, using this one, right, 1 minus cos 2 theta equal to 2 sine square theta, and 1 plus cos 2 theta equal to 2 cos square theta. This formula I have used. 2 theta and theta, x here, x by 2. Now for this formula we will use the formula that this way. If we write here now we can say here 2 is common and we can write sine x by 2 upon x by 2 whole square. So we have multiplied by x by 2, so we can write here x by 2 square and we can write this x. Okay, so limit we can take here x tends towards 0 and x tends towards 0, so we can find here 2 1 square using this formula, previous formula, sine theta upon theta, theta tends towards 0, variable should be 0. Okay, so here is x square and here is x, so what we got here, 1x is left here and here by 4 into x by 4, x tends towards 0. So now putting this value here, we can cancel out x by 2, x tends towards 0. Now putting x equal to 0, we can get 0 upon 2 equal to 0. This is your answer. Okay, so you can use this formula directly in the some questions. Now students, before going some basic question formula, I will like to describe some more formula for your further knowledge. Now, so many formulas can be drawn to using some series. Okay, using the binomial series 1 plus x to the power n, x less than 1, we can say 1 plus nx plus n minus 1 upon factorial 2x square plus n minus 1 upon factorial n minus 1 n minus 2 upon factorial 3 x cube dash 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 e to the power x equal to 1 plus x square upon factorial 2 x cube upon factorial 3 dash 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 log 1 plus x equal to x minus x square by 2 plus x cube by 3 plus x to the power 4 by 4 plus dash dash dash. Here is minus. So all this formula, if you want to know, using this formula we can maintain some questions and from formula, and we can use that directly in the limit. This is the binomial theorem, this is exponential theorem, this is log theorem. If you want to know in detail, so you should be learn the chapter binomial theorem in the previous videos, and exponential is also given in the previous videos, and this series, the detail of this series is also given in the previous videos. Okay, so you can check it. Now using this series, I am going to be writing directly the basic formula. E to the power x minus 1 upon x tends towards 0, that is equal to 1. Okay, and you can use this formula directly, and also log 1 plus x upon x tends towards 0 is equal to 1. So you can check here, if you use this formula, taking the x common cancel, here will be 1, and putting the value 0, you can find the value of 1. Okay, and one more series, a to the power x, that is equal to this way, 1 plus a x log e base a plus x log e base square upon factorial 2 plus x log e base a cube upon factorial 3. Similarly this formula. Okay, and using this formula we can also say a to the power x minus 1 upon x tends towards 0, it is equal to log e base a. So you can use this formula directly, or you can use the series and you can formulate this value. Okay, now I would like me to tell you some questions. Sine 4x upon sine 2x, x tends towards 0. Now here is sine, here is 0. It means we can formulate sine x upon x, x tends towards 0. But here is 4x. So we divide here by 4x and taking x tends towards 0. So it may be formula. And here is also sine 2x. So we can divide here 2x, x tends towards 0. So we are multiplied by 4x. So here also we have to multiply by 2x. So this will be cancelled out. Now x is cancelled and here is 2. So using this formula, limit 1 and here is also 1. What is left here? 2. So we can say what is your answer? That is equal to 2. Okay. Now we can see this question 10x upon x, x tends towards 0. Now you can see sin x upon x into 1 upon x cos x. We can write this way, taking the limit x tends towards 0. Now separately limit sin x upon x, x tends towards 0, and 1 upon cos x, x tends towards 0. Taking this formula 1 and here putting the value of 2 limit cos 0 is 1, so we can find here 1. This way you can use the formula. Okay, student. Now one more type of the question upon infinite. If we want to take questions that ax square plus bx plus c upon cx square plus dx plus e, and we are taking the limit x tends towards infinite. So how we will solve it? If we putting the here infinite and infinite, so we can find there this is the type of infinite. Okay, but we taking the common here. Let here x tends towards x equal to y. So if x tends to one upon y, so if x tends towards infinite, hence y tends towards 0. So we can put here a 1 upon y square plus b 1 upon y plus c upon c 1 upon y square plus d 1 upon y plus e. Okay, then we can write y tends towards 0. Taking the multiplying the y, we can get a plus by plus cy square upon cy square plus dy plus ey square, and we can say x tends towards 0. Now putting this value a plus b into 0 plus c into 0 square upon c into 0 square plus d into 0 plus e into 0 square, we can find a upon c. C plus dy plus ey square, c plus dy plus c e0 square, so we can find left here a plus 0 upon c plus 0 equal to a upon c. So this way you can find the answer if this is question of infinite. Okay, now next question, e to the power 5x minus 1 upon x. Now we know the formula of ex, so we can write here e to the power 5x minus 1 upon 5x. X tends towards 0 multiplied by 5, completing to this. Now it is 1, so we can write answer is 5. Okay, this way you can use the following formula. So student, we have learned in these lectures some taking the limit. Okay, now it's okay. In the next video I will describe you about that some questions on continuity. Okay, limits and continuity. So thank you for watching.